When you see oil being delivered, you assume that it will find its way to the burner where it will provide efficient combustion. But that's not always the case, and too often an appliance is blamed for a supply system problem. A typical supply system consists of many parts, starting with the tank. There are three possible locations for an oil storage tank in a typical residential system: inside the home, outside the home above the ground, and underground. The inside tank offers low cost, long tank life, easy piping to the burner, and consistent temperature of the oil, regardless of the weather, for uniform viscosity and stable combustion. When servicing an outside, underground tank, comply with local regulations. Make sure the end with the oil supply line is positioned slightly higher than the end with the fill pipe. This prevents accumulations of water from reaching the supply line and getting into the burner. It also makes it easy to pump out any water which has settled under the oil. The vent pipe should have an overfill vent whistle or alarm. Now let's go to the basement to check the supply line. Generally, the supply line is 3/8 inch outside diameter copper tubing equipped with a fusible shutoff valve. This allows you to shut off the oil flow during servicing. When the fuse melts, it automatically stops the flow should a fire occur. 1/2 inch can be used if you need a longer lift or have a higher vacuum requirement. Normally, the return line is also 3/8 inch copper tubing. That's usually sufficient for a residential installation. Make sure all fittings are tight to prevent oil from leaking out and air from entering the supply line to the burner. Join all threaded connections with a pipe compound that is oil resistant and will remain flexible. Apply the pipe thread compound with a brush, taking care not to allow the excess to overflow into the bore. Next, tighten the threaded fitting into the bore. In many installations, 2 burners are piped to 1 tank. Install a shutoff valve on the supply lines to each of the burners. The suction lines will also need a check valve or electric solenoid valve next to each fuel pump to prevent a vacuum created by one fuel pump from pulling oil out of the other pump. 2 types of filters are normally used in the oil supply line. They are the cartridge type and the spin-on type. Remove the bolt on the cartridge type filter to take out the filter element for cleaning or replacement. The spin-on type is installed and removed in one piece, like an automobile filter. The fuel pump is a vital component of the oil supply system. Here's how it functions. Oil enters the fuel pump from the supply line and circulates through the fuel pump where sufficient oil is withheld for the burner nozzle. Excess oil goes back to the oil tank through the return line. In a single pipe system, oil is returned to the gear set for recycling. Here is an inside view of the pump and its operation. The oil is pumped by a set of gears. In 2-stage fuel pumps, there are 2 sets of gears, but the operation is essentially the same. Capacities can range from 25 to 250 gallons per hour. As the oil is pumped, it is also conditioned by the gears. Small impurities are either ground by the gears into minute particles too small to clog the nozzle or filtered out at the pump. The valve assembly, shown in this cutaway model, controls the actual pressure of the oil fed to the nozzle. The pressure regulating valve assembly feeds the oil at the rated capacity of the nozzle and returns excess oil back to the tank. Pressure can be adjusted using this screw adjustment on the fuel pump. In addition to conditioning the oil and controlling the rate at which it is fed to the burner nozzle, the fuel pump also controls the cutoff of the fuel flow when the burner shuts off. Slow cutoffs cause smoky, noisy starts and stops and carbon deposits on nozzle tips, electrodes, and combustion chambers. In gravity-fed systems, where the oil supply is above the burner, a single-stage fuel pump is usually sufficient. Single-stage pumps can also be used in low-lift installations where the total lift does not exceed 10 inches of vacuum on a 2-pipe system and 6 inches on a single-pipe system. 2-pipe, high-lift installations requiring up to 15 inches of vacuum usually take a two-stage pump. Now we're going to see why airtight fittings are so important on the supply system. In a one-pipe system, air can enter at any mechanically sealed joint that is defective or loose. Air in a one-pipe system causes foaming in the fuel pump, excessive noise, and eventually the loss of the prime. Make the necessary repairs to ensure leak-free oil flow. Two-pipe systems are self-priming, self-venting, and self-purging. Because any major air leak would still be a problem and could also produce an oil leak, make sure the supply system has no leaks. Most fuel pumps are adaptable to either a one-pipe or two-pipe system. However, for peak efficiency, a two-stage fuel pump should be used in two-pipe systems only, since the advantages are lost when used in a one-pipe system. Consider the one-pipe system. The pump only needs as much oil as the nozzle can burn in an hour. 3/8-inch copper tubing usually does the job well. But because two-pipe systems move the entire pumping capacity through the suction and return pipes, it is vital that you size the piping for the job. First, check the suction gear capacity of the fuel unit. Pump manufacturers provide selection tables based on their particular pump models. For each model, you'll be told how many gallons of fuel are handled in an hour. Next, the total length of the supply lines in the system is measured using a sketch. For example, let's say that we have a total of 25 feet of lines. Now, friction loss has to be estimated using charts in the serviceman's manuals available from the various pump manufacturers. Start by reading the total feet of 3/8-inch copper tubing along the bottom of the chart. Then move straight up to where you can read the suction capacity of the fuel pump. Then move left to the vacuum figure on the left-hand side of the chart. Now you know how much vacuum is needed to draw oil through a 3/8-inch tube that's 25 feet long. Since we know that a single-stage pump, two-pipe system allows 10 inches of vacuum, and we only need 4 inches, a single-stage pump would seem like the logical choice. But what about restrictions such as vertical lift, filters, fittings, and check valves that add to the vacuum required? Start by adding 0.75 inches of vacuum for every foot of vertical lift. In this example, you have 5 feet or 3.75 inches of vacuum for a total of 7.75 inches. But there's also a line filter with 1 inch of vacuum for the filter and the fittings. Then add them up to see if you're still within the 10-inch capacity of the single-stage pump. Vertical and horizontal runs can also create friction loss. The rule of thumb here is 1 inch per foot of vertical run and 1 inch per 10 feet of horizontal run. A vacuum gauge installed in the optional inlet port on the pump or on the body of the filter can be used to check the suction line vacuum. The nozzle. Oil enters the atomizing nozzle through a screen mesh or sintered filter and travels through a set of stainless slots or tubes. Here's where pressure energy is converted to velocity energy. The high-velocity oil finds its way to the swirl chamber where it rotates toward the nozzle orifice. A spinning tube of air propels the oil out of the nozzle in a finely atomized spray. At the combustion head, the atomized oil mixes with air for efficient combustion. For the most efficient atomization, the nozzle pressure has been standardized at 100 psi. Nozzles are available in a variety of flow rates, but all are calibrated at 100 psi. Cold winter temperatures cause higher oil viscosity. This results in a higher flow rate with a narrower flame and smoky tips that form soot. And of course, inferior oil can also cause a problem with nozzle performance. Follow the nozzle manufacturer's recommendations, if available, when choosing a nozzle. Otherwise, consider the flame pattern that's most appropriate for the chamber. Then order the nozzle that will give you that pattern. The two most common patterns are the solid and hollow patterned nozzles. Because of the precise character of a nozzle's orifice and filter, nozzles should be handled with respect, carefully stored before installation, and kept from any type of dirt or damaging impact. As for cleaning nozzles, it's seldom advisable. With a low cost of replacements, it's best to simply replace an old nozzle with an appropriate new one. Now we're ready to apply the spark that will ignite the oil. We'll see that in Volume 4, entitled Putting a Retrofit Burner into Service. This volume of the Video Training Library has been produced as a service to the oil heat industry by R.W. Beckett Corporation.